Alright, so in today's video we're going to be talking about atomic structure. So just as a little background, there are two basic types of electric sources. That's going to be AC, which stands for alternating current, and DC, which stands for direct current. Greeks were the first to discover electricity about 2,500 years ago. They noticed that when amber was rubbed with other materials, it became charged with an unknown force. The Greeks called amber electron. The word electric derived from it and meant to be like amber. To understand electricity, we must first understand atoms. So what is an atom? An atom is the basic building block of the universe. We're all made up of atoms. Everything we see is made up of atoms. All matter is made from a combination of atoms. There are three principal parts of an atom. You got your proton, electron, and neutron. So what charges do each of these carry? Your protons are going to carry positive charges, electrons are going to carry negative charges, and neutrons are neutral, meaning they have no charge at all. Then you have valence electrons. Any electrons located within the outer shell of an atom are known as valence electrons. These electrons explain much of electrical theory. Moving on, we have conductors, insulators, and semiconductors. Some examples of a conductor might be silver, copper, and gold. I said cold, but I meant to say gold. Conductors are made from materials that contains between 1 and 3 valence electrons. Conductors permit electrons to flow through them easily. When an atom only has 1 or 2 valence electrons, they are loosely held by the atom and are easily given up for current flow. So some examples of an insulator are going to be rubber, plastic, glass, wood. And materials that contain 7 or 8 valence electrons are known as insulators. Insulators resist the flow of electricity. Electrons are held tightly because the shell is almost full with those 7 or 8 valence electrons. So, whereas conductors, those atoms are loosely held, or those valence electrons are loosely held in their outer shell. Semiconductors are materials that are neither good nor bad conductors or insulators. Two examples of that is going to be silicon and germanium. They contain 4 valence electrons, and when they are heated, their resistance decreases. So a little side note, heat affects conductors the complete opposite way, because when they are heated, their resistance increases. So conductors, when they're heated, resistance increases. When semiconductors are heated, their resistance decreases. All solid-state devices, such as diodes, transistors, and integrated circuits, are made from semiconductor materials. So an atom versus a molecule. A molecule is made up of atoms. So molecules are the smallest parts of a compound. For example, water is a compound, not an element. The smallest particle of water is made of 2 atoms of hydrogen and 1 atom of oxygen. So as you can see, a molecule over there on our right, there's 1 oxygen atom for every 2 hydrogen atoms. So there's a few methods of producing electricity, and those are going to be magnetism, chemical action, pressure, heat, friction, or light. Of those 6 methods, magnetism is the most common for producing electricity. Electromagnetic induction is the operating principle of all generators and alternators. You'll learn that further down the road. Electrical effects. So anytime an electric current flows through a conductor, a magnetic field is created around that conductor. So you have different electrical effects. That's number 1 is going to be magnetism. Then you're going to have chemical reactions, pressure, heat, or light. So all of this information comes from Unit 1 in your textbook. All of the questions on page 51, you're going to read the chapter and do those questions and turn them in on Canvas.